Okay, hi everybody. So in order to integrate over surfaces like the sphere, we will need to look at, I'm going to look at just this case, and it's all going to be clear here, and it'll generalize to other dimensions. And we need to think about the columns of the Jacobian matrix. So first we just have some random map, so I will draw the input and output space. Here's the input space. And here's some point, P. Here's the output space. And here's some surface that we get as the image of this map. So then I'll put, somewhere P gets sent somewhere, so I will put it here. F evaluated at P. Okay, so it's hard to point to things. Okay, there we go. In words now, I'll say the image of the map F is some surface in R3 containing every f of p, f of p needs to be in the output space for every p in R2, right? So that's the image of a map. Some surface. Okay, now I have to explain the columns of the Jacobian matrix. So let's remember. The Jacobian matrix collects and organizes partial derivatives. Now in this case, we have two input variables. We have maybe x and y, or maybe it's theta 1 and theta 2. But whatever variables they are, each input variable gives a column from what? Partial that input variable. Let's say x1. If we call this x1 and x2. And then the second column, so maybe gives a first column from this one, evaluated at P, and a second column from partial x2 evaluated at P. And these need to be columns, so the output space, there's going to be three formulas. And each of those three formulas, we can take the partial with respect to the first variable, and that gives us the three elements of a column vector in R3, the output space. And so I'm just going to sort of visually put this there and say that, in fact, I guess this would sort of be a formula. This is a formula. F dfp at some v is v1 times that first column of the Jacobian plus v2 times that second column of the Jacobian. And I'll just sort of label them, right? So the movement in the first direction, and this v is secretly v1, v2. Okay. So now I remembered this is the derivative formula, but I need to explain the columns of the Jacobian matrix and put them in this picture. These columns need to go somewhere here. Okay, so now I'm going to use words. Choosing v equals e1, 1, 0, or v equals e2, 0, 1, we see that, okay, let's choose 1, 0. Then this is a 1, and this is a 0. Okay, and you see that we see that dfp at E1 is just equal to the first column of Jacobian matrix. And we could give that a name, W1, because it's too long to write first column of Jacobian matrix every time, and it's too long to write this, maybe. So let's just call it W1. And DFP of E2 would flip it. The 1 would go over here, and the 0 would go over here. Okay, and so let's even just get rid of those. Would be the second column of Jacobian matrix, which we'll just give it a name, W2. Okay. We see that from this formula. Okay. Now we label these E1, E2, and W1, W2 in our cartoon. Okay, and that will solve the question. It wanted us to draw and label these things. Okay. So first I will draw E1 and W1. E1 is a movement like that. Right, like that. And then W1 is some movement in the output space. W1 is a vector. It is this vector in the output space coming from partial, the first variable. Okay. And it's DFP of E1. And then we could also move in the second dimension, E2. And then we would get some other movement called W2 in the output space. It is this vector right here, coming from the second input variable, partial derivatives. Okay. And so you see that like the actual map F would take this square here and send it to some sort of curvy square on the surface. That's what F would do. But the derivative takes that square, and the derivative thinks, well, it can't curve anything. The derivative is a linear map. And so it takes that square and puts it into a parallelogram right there. This is it. We have explained the columns of the Jacobian matrix by drawing and labeling pictures in both the input space and the output space. And we used our words to explain what's going on. What are those columns? Where do they come from? What are those columns? How are they related to E1 and E2? And this is my answer. This will be very important for integrating in the next question.